Okay, today we're going to start with day one, graphing the sine curve. Right before we left, we were talking about sine and cosine. We spent some time with the radian and degree of sine and cosine. But today we are going to go ahead and graph them. So the trig graphs are considered to be periodic because there's a pattern of repeating y values on a regular interval. This right here is the sine curve with no shifts, okay? Y equals sine of x. There are four main points that I want you to always consider when you guys are going ahead and doing this. The first one is right here at 0, 0. The second right here, this pi over 2 is equal to 90. So at 90 degrees, the amplitude or the height is at 1. Then we have this point right here. This is 180 degrees. So at 180 degrees, it goes back to 0. And then we have 3 pi over 2. That's 270 degrees. That right there, when sine is at 270, theta is at -1. And the last one that we're going to be talking about is at 360. So when you make a table, an x and y table for the sine curve, you're always going to start at 0 on the x, then you're going to go to 90, 180, 270, 360, and at 0 it's going to be 0, at 90 degrees it's going to be 1, at 180 back down to 0, 270, -1, and 360 you're going to be at 0. So this is with no transformations that happen to the sine curve. You're always going to go up 1, back down 0 to -1, back up to 0. Okay? So here, the radians and degrees, you guys are very, very comfortable with degree, but you guys will also, hopefully by the time we're done with this unit, become comfortable with radian. So 0 radian is also equal to 0 degree. Pi 2 radian is equal to 90. Pi radian is 180. 3 pi over 2 radian is equal to 270, and 2 pi radian is equal to 360 degrees. And we did talk about going ahead and converting radian to degree. Whenever you want to convert radian into degree, you know that pi radian is equal to 180. So if you wanted to convert this right here, it'd be 180 divided by 2 is equal to 90. Okay, so we know at 0 degree, the sine theta is 0. We know at 90, sine theta is equal to 1. We know at pi, which is 180, sine theta is back down to 0, -1, and 0. You can also put this into your calculator if you want to. You can hit sine 90 and it'll give you an output of what that value would be, which is 1. You can also go ahead, make sure you look at your mode. And if you're dealing with degree, make sure you're in degree mode. If you're in radian, make sure that you're dealing with radian mode. But you can get all of these values by just going ahead and putting that into your calculator. Okay, so now we're going to go ahead and graph sine x from -2 pi radian. Now this is in radian to 2 pi. So we're actually going from -360 to +360, if you want to know what that means in degree. Okay? So you guys go here and you guys can go ahead and do a tick mark. 1, 2, 3, 1, 2, 3, count by threes. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Here you guys can go, this is at 0. You guys, we're going to do the first one in degree and then the next one we'll do in radian. So this is going to be 90, 180, 270. We're actually going to stop at 360. And then 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is negative 90, negative 180, negative 270, and negative 360. Okay, so this is our x. Okay, and here's our x information right here. This is our y. And our y right here is just going to be going up to 1 and negative 1. So we can go 1, 2, 3. We can go to 1, 1, 2, 3, negative 1. Okay? And these are our key points right here, okay, that we're going to be focusing in on. And eventually you should be able to close your eyes and graph from 0 to 360. So you guys can go ahead and start. You can plot your first point at 0, 0. Okay, at 90, theta will be at 1, 180, back down to 0, 270, negative 1, 360, 0. And make sure that you do not have, that you don't have it going up as a point, okay? That it's a curve right down here and going there. And now you guys are going to be doing the exact same thing here. At negative 190, you're going to go down to negative 1. Back up to 0, 270, negative 271, back down to 0. Okay, and that's once the curve y equals sine of x from negative 360 to positive 360. Okay, so the domain, those are my x values. You guys can say that we're going from, if you want to write it in interval notation, from negative 360, comma, to positive 360. We're going to do a bracket because negative 360 and positive 360 part of the solution. The range, how low can you go to how high? The range, the lowest point is negative 1 to the highest point, which is positive 1. Your max, the highest point here, is 1. Your min, the lowest point, negative 1. Okay, so where it's increasing, you guys can see that it's increasing. It's going up, up, up right here from negative 360 to negative 270. Okay, that's one spot that it's increasing. It's also increasing right here from negative 90 to positive 90. So negative 90 to positive 90. And then you guys can see the last increase is right here from 270 to 360. Okay, and decreasing, you guys can see it's going down, 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 down from here, here, down, down, down here. So you guys can see that from negative 270 to negative 90, we have decrease. And 90 to 270, it is also decreasing, okay? So the midline is the horizontal line that is halfway between the max line and the min. So the midline for y equals sine x is y is equal to 0. So you're looking from here to here, the midpoint or the midline right here is right at y is equal to 0. The amplitude, half the distance between the max and the min value of the function. Since it is a distance of absolute value, this is indicating the absolute value is always positive. And you guys can see that the amplitude, or how tall or high this goes, is at 1. Okay, so we're just going to go ahead and summarize. Each cycle of the sine curve is divided into 4 parts. Its zero values occur at the beginning, the middle, and the end. Its max value occurs halfway between the min and the middle. Its min value occurs halfway between the middle and the end. Okay? All right, so now we are going to go ahead and graph this. This is going to change just a little bit. We have y is equal to 2 sine x. Okay? I want to, up here, I want you guys to go ahead and write y is equal to the amplitude sine frequency x. So the amplitude is